Welcome to Brainetainment, your trusted source for easily digested, intriguing information about the brain and its intricate workings. We're here to unravel the intricate tapestry of the human brain, translating complex neurological concepts into accessible, engaging content. Our mission is to bring you closer to the captivating world of neuroscience, whether you're a curious bystander or an aspiring medical student. Our channel serves as a bridge between the complex world of neuroscience and your thirst for knowledge. We believe that understanding our brains is not just for the experts, but for everyone who has ever wondered about the incredible organ inside their head. In today's episode, we are turning our focus to a topic that has puzzled and fascinated scientists for years: seizures. This neurological event, affecting millions around the globe, is more than just a medical condition. It's a window into the mind's incredible complexity and resilience. So let's delve into the captivating world of seizures, a neurological event that affects millions worldwide. First off, what exactly is a seizure? A question that might have crossed your mind numerous times, perhaps when you've come across the term in a medical drama or during a conversation. Well, today we are going to demystify that for you. In the simplest of terms, a seizure is a sudden, uncontrolled electrical disturbance in the brain. Think of it as a sudden storm in the brain, disrupting its normal activity. This disturbance can lead to changes in your behavior, movements, feelings, and levels of consciousness. If you've ever witnessed someone having a seizure, you might have noticed them experiencing spasms, staring blankly, or even losing consciousness. These are all manifestations of that electrical storm in their brain. Now let's clear up a few misconceptions. Many people tend to think that all seizures involve violent shaking or convulsions. While it's true that some seizures can cause these symptoms, not all do. Some seizures can be so mild that they go unnoticed, while others can be severe and last several minutes. Another common misconception is that seizures are always a sign of epilepsy. While epilepsy is indeed characterized by recurrent seizures, not everyone who experiences a seizure has epilepsy. Seizures can be triggered by various factors, including high fever, low blood sugar, alcohol withdrawal, or even extreme stress. It's also worth noting that having a single seizure doesn't mean you have a seizure disorder. The brain is a complex organ, and many things can temporarily disrupt its function, leading to a one-time seizure. However, if someone has two or more seizures that were not caused by a known medical condition, they could be diagnosed with epilepsy. So, in essence, a seizure is not a disease in itself, but a symptom of many different disorders that can affect the brain. They're not always a cause for panic, but they do warrant medical attention to determine the underlying cause and appropriate treatment. Now that we understand what a seizure is, let's examine what happens in the brain during one. During a seizure, the brain enters a state of electrical chaos. Our brain, a complex organ, is made up of around 100 billion neurons, each connected to thousands of others, forming a vast and intricate network. These neurons are constantly communicating with each other, sending electrical signals that regulate everything from our thoughts and emotions to our physical movements. But what happens when this normal brain activity is disrupted? Imagine a bustling city with traffic flowing smoothly, each vehicle following its designated route. Suddenly, a power outage hits, disrupting the traffic signals. The result? Chaos. This is akin to what happens during a seizure. In a normally functioning brain, neurons fire at a steady, controlled pace, with neurotransmitters acting as the traffic cops, ensuring that the electrical signals are sent and received in an orderly manner. They inhibit or excite neuronal activity, maintaining a delicate balance. However, during a seizure, this balance is disrupted. There's a sudden surge in electrical activity, a storm of electrical impulses that overpowers the brain's usual traffic control systems. The neurons start firing rapidly and synchronously, leading to an uncontrollable wave of electrical activity that sweeps across the brain. This disruption can cause a variety of physical and mental symptoms, ranging from minor twitching or a sense of déjà vu to convulsions or even a loss of consciousness. This intense electrical storm can be triggered by various factors, such as a brain injury, a high fever, or certain genetic conditions. In many cases, the exact cause remains unknown, but regardless of the trigger, the result is the same: a seizure, a temporary disruption of the brain's normal electrical activity. Now, Let's delve a bit deeper into the process. The seizure often begins in a specific region of the brain, the seizure focus. From there, the abnormal electrical activity can remain localized, affecting only a part of the brain, or it can spread to other areas, engulfing the entire brain. The extent and pattern of this spread determine the severity and type of the seizure. Interestingly, the brain has its own protective mechanisms to limit the spread and duration of a seizure. After the initial surge of electrical activity, inhibitory processes kick in to restore the normal neuronal firing rate. This is why most seizures last for only a few seconds to a couple of minutes. However, in some cases, these protective mechanisms fail, leading to a state of continuous seizure activity, a medical emergency known as status epilepticus. This condition requires immediate medical intervention to prevent long-term brain damage. Now that we've seen the process, we must understand that not all seizures look the same. Each seizure is as unique as the individual experiencing it. The symptoms, duration, and recovery period can vary widely, reflecting the complex and individual nature of our brain's electrical activity. So, while we've painted a broad picture of what happens during a seizure, remember that the reality can be much more nuanced and varied. Seizures come in many forms, each with unique characteristics. Today, we'll delve into some of the main types of seizures to better understand how they manifest and how they affect the brain. First, we have focal seizures, previously known as partial seizures. These are named so because they originate from a specific or focal part of the brain. Focal seizures can be further divided into two categories: focal aware seizures and focal impaired awareness seizures. During a focal aware seizure, the person remains conscious, while during a focal impaired awareness seizure, consciousness is disturbed or lost. The symptoms experienced during a focal seizure can vary widely, from sudden jerking movements to experiencing unusual tastes or smells. Next, we have generalized seizures. Unlike focal seizures, which start in one part of the brain, generalized seizures involve both sides of the brain from the onset. There are several types of generalized seizures, including tonic-clonic seizures, absence seizures, and myoclonic seizures. Tonic-clonic seizures, often referred to as grand mal seizures, are what most people think of when they hear the word seizure. They involve a loss of consciousness, body stiffening and shaking, and sometimes loss of bladder control or biting of the tongue. Absence seizures, previously known as petit mal seizures, typically occur in children and involve brief lapses in awareness, often mistaken for daydreaming. And finally, myoclonic seizures, which cause spontaneous quick jerks or twitches of the arms and legs. Now, it's important to remember that the type of seizure a person experiences depends on how and where in the brain the electrical disturbance begins. This can be influenced by a range of factors, from underlying health conditions to environmental triggers. So, while seizures can be incredibly varied, they all share a common thread. They are the brain's way of telling us that something isn't quite right. Although seizures can be frightening, they're a critical signal from our brain that something isn't quite right. As we've discovered, seizures are complex neurological events with a profound impact. They are not merely random occurrences, but intricate processes that unfold within the brain. In essence, a seizure is a sudden surge of electrical activity in the brain. It can occur due to a variety of reasons, from genetic predispositions to triggered environmental factors. During a seizure, the normally balanced electrical activity in the brain is disrupted. This disruption can cause a range of symptoms. It can lead to changes in behavior, movements, feelings, and levels of consciousness. The nature of these symptoms, as we've learned, greatly depends on where in the brain the abnormal electrical activity occurs and how widely and quickly it spreads. There is no one-size-fits-all when it comes to seizures. They come in various types, each with its own unique set of characteristics. Two broad categories are generalized seizures, which affect both sides of the brain from the onset, and focal seizures, which start in one specific area of the brain. Within these categories, there are subtypes like tonic-clonic or grand mal seizures, absence or petit mal seizures, and focal aware or unaware seizures, each with its own distinct features and symptoms. Understanding these complexities is crucial. It helps medical professionals diagnose and treat seizures more effectively. It also aids in the development of new and improved treatment methods. Moreover, it provides those who experience seizures and their loved ones with a better understanding of what is happening, enabling them to manage the condition more effectively and lead more fulfilling lives. Remember, knowledge is power, and understanding seizures can lead to better treatments and improved lives. Thank you for joining us on Brainy-tainment. Don't forget to subscribe for more brainy content.